Hi friends, in this video we will learn about how to draw a line which is inclined to both the principal planes. So here let us consider a line AB of certain length. So what are the data we can able to get in the question? We'll check it out. So what the data they will give: a line AB of so and so length is making theta degrees with HP and 5 degrees with VP, making theta comma phi with horizontal plane and vertical plane respectively. Good. And apart from these, they will give one more information, that is the position of a point. Apart from these, and also they will give position of one of its ends is given. Then how to solve this particular problem? So what are the data it was given? So a line AB is making an angle of theta comma phi with, let us consider for your clarity, I am going to draw like this. So a line AB is making an angle of theta comma phi with H, HP and VP respectively. Along with these, one end position of the line they will give. So let us consider end A position is given. So here I am going to take a generalized situation. Depending upon the values, you have to consider all the problems. Once if you are familiar with this particular problem, you can able to answer any of the question from lines inclined to both the planes. Once this concept is clear, you can able to solve any of the question. Let us consider how to solve this problem. So whenever to solve this problem, the problem is divided into two cases. Why it is two cases, sir? Let us consider why we are not going to use a single case. For example, if the line is inclined to HP parallel to VP, front view is my reference because I know the true length and true inclination. If the line is inclined to VP, I can able to view from top view length I know, inclination with VP I know. But once if the line is inclined to HP, front view is true length, true inclination we can able to get. We can able to take it as a reference. Once if you are rotated with respect to VP, why it is VP? These two ends are not equidistant from VP. So in the front view it is a reduced. In the top view also it is a reduced. And in the front view we won't get theta. Why, sir? For your clarity I will show. So here it is theta, you are going to get it. All of you observe, if I am going to rotate like this, the theta value I am not changing. This is how much height it is from this particular plane. The same height I am maintaining. But in this case what happened? This shadow will fall here, this will fall. Here I am going to get 90 degrees. Even though if it is making certain theta degrees, maybe 25 or 30 degrees, but it appears as 90 degrees in the front view. So the view inclination will be different. So whatever the theta is given, it may not appear. Then how to get the final position for this particular case? So for that, we are going to get the final solution by dividing this problem into two cases. We'll consider this problem into two cases. What all are they? Let us consider what all are they. So in case 1, line is considered as parallel to VP and inclined to HP. Case 1, it is considered as line is inclined to HP, that is it is inclined, it is making theta degrees with HP and parallel to VP. This is one case they will consider. In the first case, what they can able to consider, the line is considered as inclined to HP and parallel to VP. This is the one case. So what about the second case? What about the second case? In the case 2, we can able to consider a line is inclined to VP, that is 5 degrees, and parallel to HP. Parallel to HP. This is the second case we can able to consider. From these two cases, whatever the points we will remember, finally we can able to get the line inclined to both the planes. So in order to get the complete idea, here I am going to use certain notation. So wherever I am using red color pencil, it is related to H pencil. If wherever I am using 2H pencil, this is related to, green color is related to 2H, and black I am going to use wherever I have to go ahead with HP pencil. Notation is also important, my dear friends. That is why color coding also I am giving, because if I change the intensity, some people can able to identify, some people can't able to identify. So that is why the pencil usage, which pencil where we have to use, I am giving the color coding here. Now let us consider one end of the line is given. Let us consider here. Now end A is, so first of all we have to draw the reference line. You are already aware of it. XY line should be with H pencil. XY line should be with H pencil. So this is our XY. Now we know one end. We know the one end point. So how we have to mark it? Let us consider this is the projector. This is the projector. On this projector only A dash and A is going to be present. So on this projector, the front view of the point, I am assuming it as A dash. Top view of this point, I am assuming it is A. Top view of the point, it is assumed as A. A and A dash is known to me. Now what I said in the first case, we are going to consider, just you observe in the previous one, case 1, what we are going to consider here, the line is inclined to HP parallel to VP. Inclined to HP parallel to VP. I hope, is this position is correct or not? Yes sir, it is inclined to HP. Actually this black color one is HP. This is some above. This is some above, so it is some distance above. So this is A dash, and once, it is capital A. Once the shadow will falls from the XY line, this is A dash. So whatever the angle it will make with HP, the same inclination it will make in the front view. So this is the line will appear in the front view. So the front view is a line which will make theta degrees. Why it is theta, sir? We are assuming, we are considering the line is parallel to VP in the first case. It is inclined. Whatever the inclination it is given, we are considering it, but it is parallel to VP we are considered. Therefore, how we are going to get this? So here we have to draw a line AB. We have to draw a line AB, which is going to make certain inclination, So here it is going to make how much inclination? Here it is going to make theta degrees. It is making an angle of theta degrees. So with theta degrees it is making, and I am going to consider whether it is a true length or reduced length. It is a true length. So whatever I am going to write with blue color, don't write it in the answer. So here for your clarity I am writing this. So this is your true length of the line. True length I am going to mention it as TL. So here A dash, what is the symbol I have to use for other end? Most of the people will think that it is B dash. No sir. B dash is my final front view, but here it is my case 1. That is why I am assuming it as B1 dash. So this particular point we are assuming it as B1 dash. Why it is B1 dash? This is the front view of a point B in case 1. In case 1. So few people will have a doubt, sir, why you are giving B1 dash? Why not for A1 dash? Why you are not considering? Remember, in the first case I am fixing A. This is B1 dash front view. So in the second case I will consider parallel to HP inclined to VP, but I am not changing my A position. This is B2, second case B position. But A position, in the first case it is this, second case is this, but anyhow A position is not changing. That is why for A I am not giving the suffix 1 and 2. No sir, instead of here, if I put my reference point is here, then here it is B1 dash, this is A1 dash. In the second case, this is going to be B2, this is A2. So that is why depending upon the problem we have to do it. In the problem what I said, one end point it is given, this is fixed. This is not changing, but in the first case it is parallel to VP and inclined to HP. This is the position of B. In the second case it is parallel to HP, inclined to VP. This is the position of B. B position is changing but not A position. That's why for A I am not giving A suffix 1, A suffix 2 like that, but only B is going to change. That's why I was given it as a B1 dash. Good. So front view is over, but what about the top view? Very simple. If you observe my dear friends, this is parallel to VP. So A is some in front, B is also same in front. Same in front, or otherwise if you view from the top view line is a parallel to XY line. Parallel to XY line. Why sir? Because so once if this is the case, the top view will falls like this and you are going to rotate like this. Therefore the top view is parallel to XY line, but it is at what distance A is present, in the same distance B is also going to be present. So I have to draw a projector here. Wherever A is there, at the same place we have to draw the parallel line to it. Wherever it intersect, wherever it is intersecting, this is the projector for B1 dash, this is the locus of A. So wherever they both are intersecting, this particular point is called top view of the point B in the case 1. Top view of the point B in the case 1. I hope up to this diagram is clear to all of you, my dear friends. So which one? Line is inclined to HP, parallel to VP. So front view is the true length. This is A, this is capital B. Once the shadow will comes, it is A dash, this is B1 dash. Okay, again line, top view. This shadow will falls here, this shadow will falls here. These two shadow rays are parallel to XY line. These two shadow rays, wherever they are going to get a line, this is parallel to XY line. We got that is A, B1. I hope up to this it is clear. So from this we are going to get two observations. What is that, sir? For your clarity, let us consider this is HP. At some height, this is A dash will start. So for supporting I am taking here. So HP is this. So some height, A is going to be at some height. That is why I took this help of this particular element. Good. Now you consider this is the line I am considering. It is inclined to HP. Am I right or not? So this point is nearer to it, this point is away. This is A, this is B. So this is inclined to HP. Now the front view will fall parallel to inclined to XY line. Top view is this. From here to here is the top view length. Now what we are going to consider from this case, sir? Very simple. Now it is parallel to VP. All of you observe. It is parallel to VP. What I am going to do it now? Now I am trying to make it inclined to VP. How, sir? I am not changing in front position of A. In front position of A. But I will change the in front position of B. How? I am changing this position. Okay. Still it is making theta degrees only. Again I am changing in front position because the in front distance is again increased. I am going to increase it. So these are the various possibilities for phi. For theta I am fixing. But phi is 5 degrees. It will move to here. 10 degrees, 20 degrees, 40 degrees, 50 degrees. Like this it is going to rotate. It is going to rotate. Or observe, my dear friends. Now when the line is inclined to HP, parallel to VP, I got this is the height of B in the front view. This is the height of B in the front view. How, sir? From HP, this is A dash height. From here to here, the difference between A and B. This height is nothing but the difference between A and B. Now you observe. Even though if it makes any angle with VP, this height is not changing. This height is not changing. Am I right or not? So what is the point you have to observe? Whenever the line is making theta degrees with HP, at what height you are getting B in the front view, at what height it is there, the same height it will continue. Even though if it make any inclination with VP. Previously it is parallel to VP. At what height we are going to get B, the same height B will be continuous. Same height, because this height is not changing. Clear? But how can I able to represent that in my diagram? Very simple, sir. Observe. This is the shadow of B dash. I am showing with the finger. I am changing like this. The shadow is shifted to here. Again. So are you observe? Previously this shadow is false here. Now shifted. So B1 dash is here. When the line is inclined to VP, depending upon the angle, if the phi is less, shifted to less distance. Phi is more, shifts to more distance. So what we can able to observe that wherever I am getting B1 dash, front view will be at this height only, but it may shift from here to here. So these are the various positions of B in the front view. Various locations of B in the front view. What is the word we are going to use for representing various locations? That is nothing but locus. I am going to mention here. So once if I draw a line here which is parallel to XY line and passing through B1 dash, what is this line is called? This is the locus. All of you clearly observe. Locus of B in front view. Locus of B in front view. So therefore B height won't be changes. B will be present on that particular line only. Depends on phi. If phi is 0, B1 dash. Phi is 0 means parallel to VP, B1 dash. If phi value is increasing, B will be changes from B1 dash to. From B1 dash to it is going to shift like this. So height is not changing. But we know one word. Sir, capital letters we should not write on the with reference to XY line, because we have to use small letters only. Then what I have to do? What is the symbol we are going to use for B in front view? B in front view is small b dash. That is why we, instead of writing B in front view, we will write locus of B dash. Locus of B dash. Because of theta, the height of point B is fixed. Height of point B is fixed at this level. Good. Now, sir, is there any other observations I am doing? Yes, definitely. That you have to observe one more thing. So, Now, whenever it is parallel to VP, carefully observe. B top view will falls here. A top view will falls here. My top view length is this. From here to here it is the top view length. From here to here it is the top view length. Now it is inclined to VP. It is tilted. This shadow will comes and falls here. A shadow is here. What about this line, sir? This line length is not changing. It may be inclined to XY line in the top view, but the length is not changing. Previously, whenever it is parallel to VP, how much length I am getting here, how much length you are getting here, the same length will be continuous even though if it make any angle with VP. This length is not changing. This length is not changing, my dear friends. So this length, top view length is not changing. Therefore, this is another point we have to remember. What is that? Whatever the AB1 length we are getting here, whatever the AB1 length we are getting here, the same length will be continuous even though if it make any angle with VP, even though if it makes any angle with VP. So that's why it is called top view length. So whenever you are observing this line in the top view, how much angle the phi may be, we are going to get AB1 length only in the top view. These 2 points we have to, we got it from the case 1. We got these 2 points in the case 1. Good. Now what about the other information? So second case we will consider. What is that? The line is inclined to VP parallel to HP. Then what will happen? In the top view, if you observe from the top view, this shadow is going to comes and falls on the horizontal plane like this. Then once if you are going to rotate the line like this, it is parallel to XY line. Sorry. This is going to be inclined to XY line in the top view. This angle is nothing but phi. But we are going to get the true length. That we are going to draw here. So how much angle it is making? 5 degrees. It is making 5 degrees in the top view. At A, it is making 5 degrees. But how much is the length, sir? True length. How much is the true length? It is better to take exact value. So here A dash B dash is your true length. How much length it has? I will consider the same length in the top view also. I will consider the same length in the top view. So this is. So I am going to take the same length in the top view. So true length as radius. We are going to draw the arc. Because of space, it is not going to be have the same. 1 second. I will change it. I will move this one little bit above. Good, now I got it. Now we have to take the same true length, A as center, we have to draw the arc, we have to consider the same length. Good. So the line is this now. This is the line. Good. So what is the name we have to give? This is the top view of B in the second case. That is why I am going to consider it as B2. B2 second case top view. B point in the second case. Why you write B2? So we have to consider it as second case top view. That's why I am not giving the prime. Good, sir. This is how much length it is. It is also true length. This is also true length. Blue color things you should not write in the exam. Good. Sir, after getting this, how the front view will be? So you observe this. So the front view shadow will fall here, this shadow will fall here. So it is parallel to XY line. Wherever I am getting A dash, in the same height only B dash will also present. So I will do the same thing. So at B2 we are going to draw the projector. At B2 we are going to draw the projector. Wherever it meets the locus of A dash, means at what height A is going to be present. At this point we are going to get front view of the second case, that is B2 dash. Front view of the second case, that is B2 dash. Good. Now let us consider, up to this I hope it is clear to you. Now here also we are going to consider two situations. What all are those two, sir? Let us consider this is VP, this is VP. At some in front from the vertical plane we are considered. So this is the line. Now for your clarity I am going to take this one only, just you observe. So just my chain is vertical plane, at some in front I am considered A, some in front. So this is the line. Now here if you observe, my dear friends, two situations I am going to consider. Even you can able to observe this one in your room also. You keep a line like this. Once the angle is phi, now if you are going to rotate it with respect to HP, now it is parallel to HP. If you are going to rotate with respect to HP, previously how much in front is there, the same in front will be continuous. But if you observe in the top view, now if the shadow is here, once it is tilted, the shadow is tilted here. So the shadow can able to, from B2 it is going to travel like this. The same information we can able to represent that in the top view. How it is, that is going to be, we are going to draw excuse me, we are going to draw the locus of B in the top view, So wherever B2 is there, at that place we are going to get locus of B in top view is going to represent with small b. B in top view is going to represent with small b. Now, sir, what about front view? What we can able to observe? Now you observe front view. We are going to get a front view length is this. Front view length is pen. Once if it is tilted like this, this is also tilted. But the front view length is not going to be changes. For your clarity, just to observe. This is the line. This is the front view of it. This is the front view. So that front view length is this. Now the line is making inclined. This front view length is not changing, sir. Front view length is not changing. Therefore, A dash B2 dash, how much it is there, the same length will be continuous even though if it make any angle with HP. Now whenever it is parallel to HP, how much front view length you are getting, even though if it is inclined to HP, the same front view length will be continuous. Therefore, A dash B2 dash is the length of the line appears when you view from the front. A dash B2 dash is the length of the line appears when it is viewed from the front. Therefore, how we can able to consider this is going to be front view length. Front view length. So up to this, if it is clear to you, then we can able to move on to the next step, my dear friends. So now if it is not clear up to this, stop, pause the video and again view this one until you get this particular clarity. Then only we can able to proceed to the next one. Good. Now let us consider what we can able to know, sir. So if you observe from the front, the line length should be A dash B2 dash. A dash B2 dash. It is not more than that, not less than this. Why, sir? Because of inclination phi. Because of inclination phi, it is making phi angle in the top view. Because of phi inclination, because of phi inclination, the length should be A dash B2 dash. The length should be A dash B2 dash. It should not be more than that and more less than this. But What is another observation you observe? B should be at this height. B should be at this height. It should not be below to this B dash, and it should not be above this locus of B dash. B should be, the front view of B should be always at locus of B dash, but the length should be A dash to B dash only. A dash to B dash only it should maintain. Then how it is possible, sir? Just you have to observe here. The length should be A dash to B dash, it should possess the length. A dash to B dash only, it should have the length. The length should be A dash to B2 dash. But it should not be anywhere, sir. It should be at the height of, it should be always at the height of B dash. It should be always at the height of B dash. One second, it is shifted. 1 second, we'll make it. This position is altered a little bit. This is A dash. Okay, so in the front view, the length is A dash B2 dash. In the front view, the length of the line is A dash B2 dash, but B should not be at any position. It should be at locus of B dash. How we can able to satisfy both the conditions? Take A dash B2 dash as radius, A dash as center. Draw the arc up to locus of B dash. Draw the arc up to locus of B dash to get the final point of B. So now this particular point will become B dash. This point will become B dash. This is my final front view point. This is our final front view point. Therefore, this is my final front view. This is my final front view. A dash B dash is your final front view. This is the final front view. So good. But now the front view, how much angle it is making? How much angle? Is it theta? No, sir, it is more than theta. More than theta. So whatever I mentioned theta, that is the first case. It is not the final. Finally, the line in the front view makes with XY line is alpha. Therefore, here how much is this angle? How much is this angle is called alpha. This angle is called alpha. This is the angle made by the front view with XY line. XY line is horizontal, so anywhere with horizontal it is going to make alpha. This is alpha. I hope this is clear to you. Sir, how to get top view, sir? How to get top view? Pause the video and think about for 2 minutes and get it. Yeah, good. Few people will say, sir, take AB1 as radius. AB1 as radius because it is the top view length. A as center. A as center. Draw the arc. Draw the arc up to locus of B. Draw the arc up to locus of B. I hope this answer few people may get it. I hope that is the thing you may get it. Take AB1 as radius. AB1 as radius. A as center. Draw the arc on the locus of B. Draw the arc up to the locus of B. Am I right or not? So is it right or not? Yes, sir, it is correct. I won't say it is wrong. It is correct only. But few people, sir, I am not interested to do like this. I am not interested to do like this. Then any other idea is that? Yes. Why I have to take the top view length and draw a locus up to locus of B, sir? I have one more idea. What is that? Sir, B dash is here. B dash is here. Therefore, top view of B is also present on the same projector. And top view should present on the locus of B. Wherever those two will intersect, that is also your final point. Instead of doing like this, I can able to draw the projector like this also. Observe, my dear friends. If you draw the projector at B1 dash, if you draw the projector at B1 dash, 1 second, there is a problem. Good. Now we got it. So there are two methods are there. What all are they? So if you take AB1 as radius, if you take AB1 as radius, A as center, if you draw the arc, we are going to get the point. This is one way. Another one is draw a projector at B1 dash, sorry B dash, draw a projector at final point B, wherever it meets here. This is your final top view, that is small b. This is small b. Therefore, this particular line, the line AB, is going to be your final top view. Is going to be your final top view. Good. Now this line is going to make how much inclination? It is not phi, sir. It is more than phi. So it is considered as beta. It is considered as beta. This angle is beta. So this is the way to draw a line when it is inclined to both the planes. This is one of the most important topic for engineering people, because majority of the people will have a doubt how we got it, sir, and why we are going to draw the arcs and all those things. With this video, I hope it is clear to you. If it is not clear, just you go through it once or twice, you can definitely get the clarity. So once if you are familiar with these notations as well as diagram concept, don't think that always this diagram will come. So from that you can able to answer any of the question. So I will do one thing. In the next video, I will make what are the notations of it. If you remember that notations, after that I will take one or two problems and how to solve it also I can able to explain to you in this particular in my channel.